Yes, dear friends, here I am with another important topic, that is to understand perfect rolling on plane surface. The rolling of body of circular cross section on plane surface. That is combination of translation and rotation. In fact, here I have shown a wheel rotating on plane surface, but this body may be a disc, may be a slit cylinder, may be a ring, may be sphere, but from front it will appear that cross section is circular. When body rolls, central mass moves forward also. So when body moves a linear distance, in certain terms we say there is translatory motion. And when body rotates about axis of rotation, we say rotational motion. So here let in time interval delta t the wheel or spoke rotates a small angle delta theta, and central mass moves a distance delta x, then delta x equal to r delta theta. It is difficult to understand by student why this. Actually, angle, I generally define angle equal to r upon radius. R upon radius. So r equal to r delta theta. This is r here. So if we divide this by time delta t, so what do you get? Dividing by delta t or delta x upon delta t is equal to r delta theta. Here delta x upon delta t give average linear velocity, magnitude of average linear velocity, but we want instantaneous. For instantaneous velocity, we use limit delta t tending to 0, and hence we get v equal to r omega. By it becomes dx upon we get dx upon dt equal to r delta d theta upon dt. I have explained many times why this is there. So v equal to vcm equal to r omega. What is r? Radius of the wheel. Omega is speed, angular speed of rotation. So vcm, vcm. Now here omega 2 pi upon t भी होता है, capital T, time taken to complete rotation, and therefore if in one complete rotation body move a distance 2 pi r, then body set to rotate without slipping, and is a case of perfect rolling. And hence, if BCM equal to R omega, that is wheel travels a distance equal to 2 pi r in one complete rotation, then wheel rotates without slipping. And hence there is perfect rolling. When there is perfect rolling, no slipping means no force of friction. Because I define force of friction when a body tries to move over the surface of other, then there acts force of friction. Body is not trying to slip over the surface, so it will move without friction. There is perfect rolling. During perfect rolling, no friction acts. No friction acts between the wheel and the plane surface. So condition of perfect rolling is that VCM is equal to R omega. But there are now different cases. Number one, different cases. Number one, if VCM is equal to R omega, then simply body rotates without slipping and perfect rolling takes place, no force of friction. I have written this here. Now, in this case, the wheel rolls without slipping and no friction acts upon the wheel. In this condition, velocity of contact, yes, so wheel rotates, wheel rotates without slipping and no force of friction, no force of friction acts. In this case, velocity of wheel at point of contact is 0. But velocity of the stop point, but velocity of point on the toe of wheel is V equal to 2R omega, where omega is the speed of rotation. No force of friction act here. Wheel rotates without friction. Right? And it is equal to twice VCM. जो यहाँ के ऊपर पॉइंट होगा, the velocity of that point will be twice VCM, while at bottom it is 0. It is here VCM. Now number 2. These points are important. I will explain one question. Then you will realize the discussion of all these points. If VCM greater than R omega, अगर आपने व्हील रोटेट करना था और आपने स्पीड दे रखी बहुत सारी and you release on the surface, then what will happen? In this case, the wheel will slip forward. In this case, the wheel will slip forward, slipping forward direction. Forward direction, and hence force of friction will act in the direction opposite to the direction of VCM. So I am explaining here कि V ओमेगा जो है greater than VCM greater than R omega. So wheel will be slipping forward and force will act backward. This is central R. Direction R this. R into F क्या होता है? Torque. R into F torque. VCM equal to R omega. Greater than R omega. Leap forward, force will backward. R cross F. है ना? तो torque will act on this which will increase the which will increase the angular velocity. So torque vector will R cross F. So torque here produced. Direction of R is this, F is this. So it is it will produce angular acceleration. And this force of friction retards the linear motion. The force of friction acts in opposite velocity. And this force of friction will produce linear retardation, which will decrease the value of the magnitude of VCM. This force of friction will produce torque. Dear friend, here it appears little difficult why torque is there. I told you tangent component of force produce torque. So on this wheel, the force will acting tangentially. Force of friction into this R will produce torque, and this torque will produce angular acceleration. This torque will produce angular acceleration. Will produce angular acceleration. Which will increase angular velocity. Due to sloping of wheel, there will be force of friction in backward direction. Wheel will start slipping in forward direction, force in backward direction, and this force of friction retard the linear velocity and increase the angular velocity because torque is produced. This will decrease this after certain time. After certain time interval. Decrease of linear velocity, increase of velocity. After certain interval time, the condition VCM is equal to R omega takes place. And hence perfect rolling begin. And hence perfect rolling begins. And force of friction disappear. थोड़ा सा मुश्किल लगता है समझना, but this is very important for your students. Listen, actually, traditionally in schools, classes, we people, students also do not like to study too much. They always want to enjoy the time. But no, class 11, this is topic class 11, and the class 11 is the base year of our career. If we want to be engineer, doctor or any scientist, then class 11 teaching or learning is very basic. Like you can't make a house if you don't have basement strong. So this is your base. So perfect rolling begins when VCM equal to R omega. So when VCM is more than R omega, the V, I am explaining again, when VCM was more than R omega, the wheel slip in forward direction, and due to that slipping force of friction in backward direction, that force of friction here retards the linear motion and increase the angular motion. So this will be taking place till the condition VCM equal to R omega. Now case 2, when VCM less than R omega, Number 3, VCM less than R omega. Please comment after reading this whole topic, watching the complete video. Have you understood or not? When wheel has velocity omega less, then in this case wheel slips backward direction. भाई ओमेगा मोर देन ओमेगा बड़ी होगी तभी तो वो VCM लेस देन ओमेगा होगा आर ओमेगा. तो wheel will slip forward direction, backward direction. Slipping this way, the force of friction acts forward and backward. Hence, force of friction will act in forward direction. This force of friction will produce linear acceleration and hence will increase the value of VCM. Secondly, force of friction will produce a torque which produces angular retardation. Hence, angular velocity will decrease after some time. Condition VCM equal to R omega is achieved and hence perfect rolling begins. And force of friction disappear. Force of friction F disappear. So this is the condition of perfect rolling. Perfect rolling take place when VCM is equal to R omega. Thank you.